What's up, GERO 200? Hey, it is Sunday, January 28th, 2024, and we're going to be entering week 4. And I would say welcome to all of the people that added on GERO 200. Yeah, we added all the way through Friday, the end of week 3, to get all our ads in. And it's great that you joined the class, and you're going to be brought right up to speed along with everybody else. Contact Julia, okay, and she will educate you in terms of what you need to do to catch up. The way you contact Julia, of course, you go in the syllabus, you get her email address, okay? I'm not going to do that. You can do that yourselves. And the other thing that you should know in terms of catching up is you go right over here, okay? We have all these different folders, so to speak, right here. And so what we have over here is, hey, guess what? My dogs are barking again. Go figure. Let's see, GERO how-to folders, okay? And so you come in here, okay? And it says how to get an A in GERO 200, okay? So this is the first thing that you're gonna do right here is you're going to watch this video, all right? And it's gonna explain to you how to navigate GERO 200, okay? And then if you scroll down right here, it's like all these different explanations, and on and on and on and on and on, everything you need to know, okay? So how to look at your own quizzes, Blackboard help, what to do if you just added GERO 200, right? There's Julia's email address right there, as promised, okay? Alrighty, she kind of goes through the quizzes and the discussions you have to make up. And yes, we have a weekly quiz and a weekly discussion. The first writing assignment is going to be due on February 12th, so that's 2 weeks away. There's already, if you click into this right here, click into this, and takes you to that part of the Blackboard course. And again, this is the original Gangster 100% online asynchronous course. So this right here is everything you need to do in terms of doing this writing assignment, all right? Due in 2 weeks, all right? It's about 2 pages of text and 2 pages of figures. You're gonna do some data mining. These are the sites you're gonna go to get the data, okay? Very clear explanations. And then here's a how-to video from last semester, and what I'll do last spring. And what I'll do is I'll be making a brand new one for you, right? But that's down the line, okay? So you're all good. All right, so what are you gonna do then? You're gonna go into your weekly assignment. Like I said, we are in the 4th week, which is awesome, all right? So we're already got a pretty good flavor of why aging is important. We spent the first 2 weeks kind of looking at the global reasons for this, and it's really about preparedness, okay? And so the reality is we've extended the lifespan. There's a lot more longevity. That being said, there's still a lot of issues associated with getting older, and so how do we as a society prepare for that every step of the way? In week 3 we talked about how you go about studying populations. So you'd be a demographer or maybe work for the CDC and do public health, okay? Every state and local community has their equivalent of kind of a CDC that's involved in public health. And as we went through here, we kind of documented, okay, here's the reality. A lot of countries got there a lot earlier because they're old world countries, all right? So if you look at France, or you look at Germany, you look at Italy, these countries have been around for a long time. They are developed countries, also referred to as westernized countries. Their economies shifted. They had far fewer children each generation because they became a much more kind of industrialized, corporate level of society. And so they had to adapt and they had to make changes. Okay, a lot of them are slow. The Nordic countries have done really well. Okay, Norway and Sweden and Denmark. Okay, they figured this out. Okay, and we're going to get into this in terms of, for example, financing the well-being of their older population. Through proper taxation and then redistribution of the funds through what we call entitlement programs, our version of Social Security and Medicare, all right? Some countries are all screwed up. Italy, Greece, Spain, they've got this burden, financial burden of, hey, how, we can't just get rid of our old people, right? So we got to finance their well-being, and it's a big issue. And a big part of that has to do with the basic biology of aging and how understanding the biology of aging, but the reality of aging is it is the biggest risk factor for 99% of all diseases for which people go into hospitals. All right. Yes, you can have your sports injuries that result in orthopedic surgeries. We have childhood leukemias and infectious diseases, but by and large, our big burden in terms of money spent in our country and every country worldwide is cardiovascular disease that results in kidney failure, cardiovascular disease that leads in heart attack and stroke and on and on, okay? The diabetes that underlies that, okay? And respiratory diseases from cigarette smoking, and then we can also look at cancer, which is an age-related disease. For the most part, there are childhood cancers, but for the most part, it's accumulation of damage and vulnerability. Okay, and so we're going to look in this week 4 of what about aging is kind of setting us up, and then really what can we do to modify the course of aging so that we spend less time in this burden disease condition? It's it's psychologically a burden. I've had a lot of orthopedic issues, arthritis, and other age-related disease. And then the financial burden of that. I'm having to bill my insurance company a lot in the last couple of years because of all my orthopedic surgeries. So if we can figure out maybe the aging part, maybe we'll also reduce the disease part. And that's where everything is headed. Okay, guys? Awesome. Alrighty, so the best approach now that we've entered the week, if you're new to the class, is you'll see this is, there's a video, and I explained the basics of the video right here. Okay, and this is how we roll in this class. There's a PDF file that is reading. It's like 9 pages long, but what I'll do is I'm just going to go through there and target. Okay, this is what you need to know, or if you need to find it when you're taking the quiz, and I'll explain that in a second, this is how you would go about finding the information in the PDF file, okay? Alrighty, this is figures that really support everything that we're going to be talking about right here. And if we scroll down here, right here, there's a quiz and a discussion. And the discussion is based on this week's assignment. And so we're honing in right here on cell division, okay? The factors that limit cell division, you're going to learn about this at the very end of the chromosome called the telomere, and then how that affects reproduction, okay, and fertility, which is a real life scenario for you guys, because you guys are weighing, do I have kids? Do I get my career? What if I delay? Am I going to be able to have children? These are real life scenarios, okay? Awesome. All righty, so let's go back to this right here. This is the quiz. So what I suggest one approach is come in here, okay, and we are going to open the course a second time, okay? Awesome. And then what we're going to do is we'll go down here to the same weekly assignment section. We're going to go down to week 4 because that's where we're at, okay? And what I would do is scroll down here, and there's my quiz. I'm just going to hit it. I'm going to hit continue, okay? And there it is. So there's my 5 quiz questions. Now, we derive these quizzes from all the material. There are 30 questions in the pool, and so it randomly puts them into the quiz that you take, okay? So no two of you will get the same quiz, but you are free to work together with your friends and go through these assignments and figure this out together. You could have 3 quizzes almost simultaneously with the 3 of you and just go back and forth, okay? It's all good, all right? And so this way you can go back and forth between the material and the quiz, all right? Okay, and then once you get done with the material, you'll have a better background for doing the discussion posts that I'll go through. All right, guys? Awesome. Okay, so let's get into the essence right here. So we're gonna do the video, we're gonna go over the reading, and then we're going to go over, this is kind of a review of what's going on, and some current approaches that might be really valuable. These current approaches, just going to, take a little step back. This is big money, my friends, okay? So the billionaires around the world are funding giant corporate pharmaceutical biotech investigations into what can we do to slow the aging process that's making us so vulnerable to disease. Because what we want to be able to do is maybe extend the lifespan so we all live to 105, but more importantly, so we're out there playing tennis, having this optimal life all the way to the bitter end. All right. Too often right now, we may, up through 55 years of age, be okay. And then all these diseases creep in. And maybe if we had just altered the course of the aging process, that this whole area gets compressed like we see right here. Not have 40 years of diabetes, not have 40 years of arthritis, cancer, et cetera, et cetera. That's the concept, guys. And so these guys are fully into it, okay? When we look at these different approaches right here, and I'll take, just kind of show you one example. And this is, the Bill Gates, Jeff Bezos example. It's called Altos Labs. You can tell I was kind of looking at it a second ago. And you come in here, this is a huge career opportunity. Okay, this is big time. All right, the business side, the science side. If you guys are gonna be maybe becoming fund manager for a large investing group, okay, like a Morgan Stanley or a Citibank or Fidelity or Vanguard or whatever, if you had a better understanding of all this, then you can then tell your bosses, hey, this is what we're going to fill up our mutual fund bundles with, and then you can sit down with your clients and say, hey, I really think Altos is a good idea based on your reading. All right, so this is all about what they're doing. Okay, again, it's all about kind of medicine that is going to rejuvenate the way cells work as we get older. Okay, and so there's all kinds of information on that. Again, rejuvenation is the hot topic word. Okay, and then you can scroll down here and take a look at opportunity. And there's opportunity about many ways. Careers, okay, lots of opportunity down there, whether it be marketing, sales, investing, okay, or being a scientist. Okay, so it's a big deal, all right? And that's just one of many. Larry Ellison from Oracle fame, he's invested into a completely separate anti-aging group. There's the guy that founded PayPal. His name is Peter Thiel, and again, he's thrown just hundreds of millions of dollars at another entity. So this is the reality. This is all part of your future. Okay, so what are the basics? Okay, so we'll start here with this video. Watch the video. Just sit back and enjoy. Here's the key issues that's going on in this video. Okay, so there are certain types of tissues, okay, in our body that have to undergo cell division for replacement. Every single part of your plumbing that is your vasculature is constantly renewing itself, okay? So when it doesn't go right, okay, then that maybe contributes to the vascular disease that can lead to a heart attack, a stroke, kidney disease, blindness from diabetes, on and on and on and on, okay? Skin, okay, that's a huge market, okay? Right now, it's, we have a lot of products that you can get in terms of special types of lotions that, are marketed to women for the most part. To get rid of wrinkles, we have, Botox injections, okay, on and on and on. But if maybe we can get in, because the big problem with the wrinkles is the rate of cell division is slowing down. Cells die off, and nobody goes in there to replace them. All right, and even those cells that are in there are not working as well, and that causes another process that leads to the wrinkles, where the protein, your springy proteins called elastins, lose their elasticity. All right, so that's a problem. All right, so we don't have enough cells that are replacing the old ones that we get rid of, and then another big problem is some of the old ones that we need to get rid of, we can't get rid of it. They become sickly, okay? And we have a natural process of kicking out these cells, but the problem is sometimes they figure out a way to bypass that process and all they do is take up space, okay? And so now you have a limited size for an organ or a kidney, and but now, you know, half of that factory is taken up by workers that don't do anything. So that's a big problem, okay? So something that we do have control over, okay, that has become a big deal is nutrition, okay? We know that overnutrition, as we see right here, okay, contributes, okay? It's not the only thing there, but it contributes to a lot of different diseases, okay? Alzheimer's and Parkinson's are completely correlated to diabetes and obesity. Okay, Alzheimer's is now called type 3 diabetes when we get into the diabetes section, because it's the vascular disease that comes from diabetes that causes Alzheimer's. Okay, overnutrition fuels the production of cancerous cells. All right, so if you could limit your nutrition, then you got something going on. Diabetes is a risk for both cancer, diabetes, heart disease, on and on and on and on. All right. So that's a big part of it is nutrition. And so it's a big fad now. All right. So what we do, and it's not just a fad, we're trying to get back to who we were biologically as human beings, as a species, for 99% of our existence on Earth. Okay. It's only recently we've had unlimited food and we've had to behaviorally regulate how much we take in. Okay. Our ancestors of Cro-Magnon and cavemen and Neanderthal and on and on and on, and even, you know, more recent times, okay, the Romans and etc. Food was limiting, you know, and so overnutrition or obesity was not a thing. Okay, we would go out there and we'd chase down food, we would eat it, we would just purge, gorge ourselves, and then we might go, you know, for 4 or 5 days with nothing. Okay, and so you would go through the cycle of feasting and fasting, and you would more than likely keep this normal body weight. Modern society, we've created our own problems in terms of what we call developed/westernized society. So we have to behaviorally regulate it. So nutrition is a big deal. So there's all these different businesses that will guide you in terms of doing the intermittent fasting or eating food that helps you fast. Okay. The Mediterranean diet, you know, the blue zones are all about eating 80% of what you thought you were going to eat, on and on and on. Okay, that's what that's all about. Separate from this, okay, they talk about this one compound, okay, that is a kind of a nutrition sensor inside all of our cells. It's kind of way beyond the levels of this class, but this one compound, if you're not eating, it goes up. Okay, it's called NAD+. And what it does then is it goes around to your cookbook, your DNA, okay, your nucleus, where your chromosomes are, and it goes in there and says, these are the different genes we need to turn on to make our cells last, to be healthy until the next cycle of food comes in. All right, that's what this is all about. All right, then you fast forward, a little bit of science can go a long way in terms of business promotion and sketchy kind of nutritional supplement industry. And so there are tons of companies out there now that are take this little bit of science and are promoting you take these supplements to elevate your NAD and you're going to be free of disease and last forever. And my take-home message is right here. You know, eat a balanced meal. You'll be fine. Exercise. Don't even consider relying on these compounds because it's really not, the science doesn't really match the reality of life. All right. Awesome. Okay. We have stem cells. All right. From which a lot of our tissue comes from. Not our brains, not our hearts. Okay. Early on when we're embryonic, they come from stem cells. But then we have we're born and we have pretty much our full allotment of heart cells, muscle cells that are associated with our skeletons and our brain cells. Okay. But every other cell throughout our bodies comes from these stem cells that are not committed. They get the necessary signals and they divide to make whatever type of tissue. They can make a new liver, make new kidney cells, make new vascular cells, like I was talking about. The most important one I can think about is all of our blood cells, our red blood cells, and our immune system cells. Okay, we produce over 200 billion brand new white blood cells, immune system cells, every single day. And it starts with these stem cells. What happens over time, it's been shown, biologically in the laboratory, that the rate of producing new cells when you get older, okay, slows down, and these stem cells begin to die off. And so now you're coming from a very limited framework. So I cannot donate my bone marrow for a bone marrow transplant because I don't have enough stem cells in my bone marrow to make it worthwhile for the person that would be receiving it, right? Awesome. Okay, so we're going to talk about these stem cells when we talk about, scroll down here, our discussion, okay? Because a big part of stem cells, sorry, has to do with the essence of reproduction, okay? Whether it's the production of new sperm every single day, okay? Or the production of cells that support the egg and ultimately you getting pregnant as a female, all right? So these are all really, really important factors that are related to the stem cell concept. Okay, all right, so quick review, right? Before we go into the reading. It was also in the video, all right? So every time a dividing cell, a stem cell divides, the very tip of the chromosome gets shorter. This is like a time clock, so that now my stem cells are working more slowly, and then finally they get exhausted and they don't work anymore. All right. Now, so that's a limiting feature in terms of putting in new cells. An important feature of these ends of our chromosomes is there are caps on the DNA that protect them from compounds that cause mutations in the DNA that can lead to just abnormal protein production right here, okay, or damage that can lead to, for example, a mutation, okay, that can cause a cancer. So the classic damage in terms of the error in your genes would be what's called an oncogene, okay, and this is where, for example, a gene that says, okay, there's a whole series of genes, but to say it's time to grow as a cell and cause brand new cells to be formed. And, so the classic example is we produce new red blood cells. They're replaced out, they last about 120 days, okay? But like I said, we're making these new white blood cells and red blood cells all the time. If there was a replacement rate of let's say our gastrointestinal system, where it's about 20 days, okay? And then suddenly now you're replacing the cells because of an oncogene every 2 seconds, okay? Now you got a problem, now you got a tumor, and the cells that are being put in there are not working right. So that's this concept right here, all right? Like I said, sometimes cells won't go away. That screws things up, okay? The metabolic problems can be inefficient use of our fuels, and then when the mitochondria aren't working, they can cause tissue damage. All right. So these are all related. So if we look at Altos Labs and those kinds of companies, what they're doing is, hey, we're gonna develop some new stem cell therapies. So maybe we can just grow tissue banks of stem cells, and we can test you and say, oh, you have suspect stem cells. Here, for a fee, we'll give you these ones. That's kind of where the future is, okay? We can, again, rejuvenate the blood. And there's a concept of getting rid of the old beat up cells, okay? Getting rid of the old beat up mitochondria and putting in brand new ones. We know that this is a fancy word for fasting, okay? Dietary restriction, or just the Mediterranean diet, we don't eat as many calories, okay, is really important for activating this molecule, and this molecule. That is key for looking at a cell, making that cell repair all its damage and last longer, right? So there's a lot of research looking at this, okay, where we can take compounds that might be rejuvenated. There's a molecule called rapamycin that's been around forever that's really out there of, hey, maybe we'll just take this rapamycin molecule and slow the aging process. So there's some evidence that works, okay? On and on. So we got to turn on, and that's what epigenetics means. We have our genetics, which is our 23 chromosomes, our 20,000 genes. Which ones get turned on and off at any one point in time? Let's figure out how to tap into those ones that get turned on when we exercise or when we eat a really good meal, okay? Let's figure out a way to turn off those ones that get activated when you're all stressed out. So that's what this is all about. So this is a big, big, big business, guys. Okay, so this is what the face page looks like on this article right here. I'm going to go ahead and tap into it. Okay, and we're going to come over here. All right. All right. I'm going to click on the arrow. Luckily, it's one of those kind of PDF files so I can scroll down. Okay, and we're just going to kind of again. I would read this not for detail. Okay, you can open your quiz, okay, and look for the hot topics. Do remember when you're in a PDF file, okay, you can always search, okay, like so. It says I hit edit, I hit find, and then I can find anything I want to look at, okay. So how about STEM? All right, so we can do STEM next, okay. There it is, all right. So that's from systems, okay. How about the next one, okay? System, okay. So that wasn't the best word. System, all right. System. All right. So it wasn't the best word, okay. How about here? I'm going to go back up here. I'll find a better word. Huh? How about telomere? So that's the cap on the end of your chromosome. So I'll go like that. There, I got some telomeres, okay? So maybe that's how I'm going to go about finding things. Anyways, that's just an example of what you can do. All right, let me get out of that search function here. In terms of my PDF files. Come on, go away. Okay, cool. All right, so let's get back up here, all right? And what we're going to do is we're going to scroll up here. We're going to start at the very beginning, okay? All right, so time's a wasting, okay? We only have a limited amount of time on this earth, you know. How do we age? Why do we age? All right. Theoretically, the idea is, you know, we want to keep passing on, kind of like shuffling a deck of cards. Keep, Darwin, better and better genes by basically having, this random introduction of genes through reproduction, and then depending on the environment, okay, those genes play out to give you this successful advantage to survive longer and pass your genes along to the next generation. All right, so that's part of the concept. So we don't want people sticking around forever because we got to keep the diversity, okay? All right, so we ask, how do we age, okay? And like I said, one of the first things that was discovered, okay, pretty simple stuff, and this has been reinventing the wheel. This has been seen over and over and over again. There was an ancient study, not ancient, study from about 40 years ago, done in China, where it was noticed that people, especially when China was still in a very much so developing country mode, where there weren't a lot of resources, there weren't excesses in food, and there's more of a reliance. We see this in terms of poorer nations, more reliance on a more vegetarian diet. Okay, lots and lots of beef. That's a luxury. I think it takes like 10 acres of land to make one cow or something like that, whereas you can make ungodly amounts of soy or whatever else. So yeah, so it was noticed that it's called, that first documentary was called Forks Over Knives, okay? Meaning you can eat something with a fork versus having to cut it like a piece of steak, okay? And basically, people that were more vegetarian diet had less disease and lived longer. We see that in the laboratory. So we can look at rodents. We can do anything. We can actually look at worms, and there's a whole field of aging where people look at the exact same type of worm. Why look at a worm? Because it only lasts 30 days. So if you get a worm that lasts 50 days, you've doubled its lifespan. So you got something and you've done it real quickly. And then you look for those genes in the worms and say, hey, does the same kind of gene happen in the fruit fly, the Drosophila? It does. And you get the same outcome. And then, hey, lo and behold, we see the same type of kind of age modulating genes that happen in mice and in rats. And then lo and behold, we see the same thing in primates, okay? People like us, okay? Humans, okay? Species similar to us, okay? So it was very clear that when you limited the diet, certain genes turned on and certain genes turned off. When you had unlimited access to unlimited food, other genes turned on and other genes turned off. And they were associated with the well-being of the animal. restricting intake in mice. They may be half the size of an obese mice, okay, but they live twice as long, all right? So pretty interesting stuff, all right? And so from that, then we get a framework of how to apply this to the human situation, okay? All righty. So we come down here, okay? So the concept is aging is not programmed, okay? It's and this is where, okay, all the the billionaires are coming in. It's not programmed, then maybe we can modulate it. Okay, that's a theory. Okay, certainly we're seeing that we can modulate the blueprint so that people live longer, so that worms live longer. Okay, on and on and on and on. You can go in there and do genetic manipulation in a worm. You can just go in there and grab the gene that is associated with overnutrition, pull it out, so it's no longer in the animal, and lo and behold, the worms live longer. So now you start having a target. Okay, alrighty. We look down here. Okay, when you have excess, okay, one of the big things is we look at diabetes, which is a really current human epidemic. Okay, we have an epidemic of obesity-related diabetes, especially in the developed countries like us, the United States, but really worldwide. Okay, and what happens, and when you have too much sugar, then they talk about it right here. Is it cross links or takes proteins that are normally doing stuff in your blood or normally doing stuff in your cells that we really need to have done. What happens is a sugar molecule gets attached to it, and then that sugar molecule attaches another molecule, and suddenly it's like a beaver dam. Okay, nothing's working right. Okay, and so sugar attachment. Okay, we see this as the kind of like the beautiful brown molecules that when you charbroil a steak. Okay, that's all what are called advanced glycation end products. And these advanced glycation end products keep cells from doing their job. And also the immune system flips out when it sees this, and it causes major inflammation that underlies all of our diseases. Okay. Alrighty. Here's an example right here. My skin, all right, gets cross-linked. It doesn't do it as well. Same thing. Anything that's going on in the skin is happening in terms of all of your vasculature, so all your arteries and veins, and they don't work as well. And then you run into problems in terms of hypertension and aneurysms that burst and on and on. Okay, awesome. That's the idea of that. Okay, so okay, cross-linking can happen at the level of the DNA as well. And then you got a problem. You got a mutation, DNA damage, so that the cell doesn't work as well. Worst case scenario, you got a mutation. All right. All right. So we can look at kind of the gene concept of it and looking at evolution in terms of the senescent theory of age. Senescence is just aging. Okay. Some things that are good for us early in life can be bad for us if we were to live longer. All right. So they give it this horrible name. Okay, it's called antagonistic pleiotropy, which means something that gives you an advantage in your youth. If you keep tapping into that later on in life, well, you're not supposed to be living anyways. You should, your offspring should be alive and you should be dead. And this stuff's going to make sure that you do die. So that's the concept. All right. So we have right here. Here's an example. Okay. So this is a gene called P53. All right. So P53 is super important for detecting DNA damage. Okay. All right. And any cell that doesn't look right, all right, boom, you get it out of there. All right. And you kill off that cell. All right. But this also is going to slow down the rejuvenation of new cells. Oh, I have an idea. Why don't we just inactivate P53? No, because DNA damage is what underlies cancer. So there you have this kind of this double-edged sword. When we eat a lot of nutrition, there's a hormone that gets elevated. Another example of this kind of good now, bad later. Okay, and I'll scroll down here, and it's in the kind of endocrine part. Okay, so when we have a lot of food coming in, our pancreas releases a bunch of insulin, says here comes all the sugar, and then our liver releases this hormone called IGF-1. This says here comes all the sugar and here comes all the fat and protein. All right, so it tells all of your cells to take it all up. Okay, and then since there's so much building blocks, so much nutrition around, go ahead and just go crazy on cell division right now. And don't repair the cells, because you know what? I'm pretty sure later on there's going to be a problem in terms of food. There's going to be that kind of caveman fasting, and then that's where we're going to repair everything. But guess what happens? In our present society, pedals to the metal in terms of unlimited food all the time. This drives cells to undergo cell division, and you don't repair these mutations, and you got real problems. All right. So that's kind of connects the two between this like good and bad idea. Another one is our stress hormones, adrenaline and cortisol. We need that when we're being chased by a lion, okay? But we don't need it thinking about, oh my God, how am I ever going to get into grad school, or am I ever going to make enough money to have a comfortable living? You tap into that stress system all day long, it's bad for you. We need that stress system when, say, you come around the corner and somebody tries to beat you up, then you just, and it's over, all right? That's another example of good now, bad later if you're tapping into it all the time. Here's a mitochondria, okay? So a big part of that mitochondria concept has to do with free radicals, okay? And so we need to get rid of these mitochondria. The problem is, if you don't get rid of the mitochondria and have turnover, then it's like having a really old car with all this crap exhaust coming out of it, okay? So this is the drill with our mitochondria. We need to get rid of them. How do we get rid of old ones and put in new ones? Like I said, when you're fasting and exercising, the cell hunkers down. It says we got to repair what we have. So it gets rid of the old mitochondria, it puts in brand new one, and that is super important, because then the free radicals that we all take our antioxidant vitamins for, and eat our blueberries for, are not going to be produced by the mitochondria and other sources. All right. So that is the drill. We kind of did everything in terms of what is important in terms of the basics of aging. There's more out there, guys, but those are the basics, okay? It relates back to everything I talked about here. And then right here, this is some of the directions that we can go to improve the aging process, okay? And that's what the ultimate goal is. We're going to have targeted therapies, targeted nutrition, how to reduce stress, wellness, okay? That's a big marketing thing, exercise, on and on and on, so that we're going to add life to years, okay, and make things better, okay. We gotta make ourselves more prosperous during our lifetime on Earth. All right, so that's what that's all about. Make sense, guys? Perfect. Okay, now, like I said, one of the limiting factors is our stem cells, okay, where they get exhausted, and telomere shortening, okay. So we're coming over here, okay, and we're going to look at our overall goal of our discussion, okay. So we're going to relate this. Here's the basics of this, okay. Telomeres are important not only for women, but also for men. Now, you are born with your full complement of egg cells that can get fertilized, but the egg cell is just only a small part of the ovary. The ovary is housed in all these collections of cells. It's like a sphere, okay? This sphere of cells, okay, it needs to undergo massive cell division to create the perfect environment for the egg to be released, and then that's when the sperm will fertilize it. Okay, all right. So if this sphere of cells, okay, does not undergo maturation, then the eggs don't get released. The eggs don't undergo maturation in the correct way, and you're not going to get pregnant. Okay. Bottom line. Okay. Okay. It contributes to a lot of problems as well. Okay. So this concept in your ovary, it's called a follicle. Okay. It also, as you go through the whole cycle that you go through as a female every month, it's really important for the hormones that are absolutely essential for undergoing the process to become pregnant. All right, and so you have this increase in estrogen, all right, so that now your uterus grows and grows and grows. It becomes the perfect nest for a fetus to develop, okay? But if you don't have the right cell division in your ovaries, you're not going to have the right levels of estrogen and progesterone. Your uterus doesn't form right, and you'll never get pregnant, right? So that's kind of a simple take-home message, okay? So we can look at the kind of the yin and yang, okay, that has been discovered in um, uh, um, uh, people that have long telomeres, okay? Long telomeres, okay, increases the lifespan, all right? If we look at people with long telomeres, okay, all right, we see that we have right here, it says fertility factors associated with long telomeres and fertility factors or deprovement associated with shorter telomeres. Okay, so you're going to last longer when you have long telomeres. Okay, that means you can have multiple births. Okay, you have elevated levels of estrogen for a longer period of time to keep your body ready to get pregnant. Okay, um, you can have one other problem right here, and in that levels of estrogen for the lifespan are a risk for ovarian and breast cancer. All right, we come over here. All right, so we look at men. Okay, so we have two types of cells in our testes. One's for making testosterone, the other's for making brand new sperm every single day. All right, so with the telomeres that undergo cell division to produce the sperm. Okay, if you have long telomeres, remember those caps protect the DNA. All right, so you have really good DNA. You have lots of maintenance to protect any errors. Okay, you have a good sperm count. The sperm that you produce are kicking ass. Okay, nice long telomere. That's that red cap. Okay, short telomeres over here. You don't protect the DNA. The DNA gets cut up, fragmented, mutated. Okay. Um, you have lower sperm count, okay, because now the telomeres dictate how fast cell division is, and because the genes that are, guiding the sperm are all screwed up, they don't work very well. All right, so let's just go down here now. Look at how this translates. This is a really cool article about fertility, okay, and looking what happens, and both men and women contribute to this decline in fertility. All right. So we're looking right here. This is maternal age. This is fertility rate. And again, you guys should in your 20s should have 3 kids already, 4 kids. That's what we're biologically designed for. But we don't. We hold off. We go to college, okay, right here. We go to grad school maybe right here. We get our careers in order right here. And next thing you know, you see that the fertility is dropping off. It's like maybe 60% of what it was. And then out here it just plummets, okay? And what we see also is because the cell division is not right, their hormones are not right, so you're not really, the ovaries are not communicating with the uterus quite right, and so we see that as a result, the number of miscarriages, also called spontaneous abortion, skyrockets. All right, so this is it's a tough decision. Okay, alrighty, so. One way to find out how you're doing and how your ovaries are doing, all right, so this is your ovary right here, is you can test a fertility drug, okay? This is a cool website. I'm going to take you there in a second, and it's something that you might pursue someday if you're having fertility issues. Maybe you finally have found the right partner. You're in your late 30s, and lo and behold, you can't have children. So then you go see a fertility specialist, an MD, that uses these practices. Okay, one of the drugs that is used is called clomiphene. But how clomiphene works, okay, is it actually blocks the ability of the brain. This is the part of the brain right here to sense estrogen. All right. So the way your cycle normally works is you produce this hormone right here that goes down to the pituitary that releases these hormones into your blood. This follicle stimulating hormone goes here. Here's your follicle, the one that undergoes cell division that we were referring to when I was talking about up here, your telomeres, okay? Alrighty, so what happens is the FSH causes cell division, okay? And you can see the egg is getting placed into a bigger and bigger house, and finally the follicle ruptures, releases the egg, goes down the fallopian tubes, and hopefully, lodges inside the uterine lining and gets fertilized. And you have a baby, all right? And in the meantime, it goes through a different phase of hormone production, all right? Okay, so what happens during your cycle is more and more and more FSH gets released, okay? Um, um, and this is, only going to be stopped by the transition that happens down here. Now, we can fool the brain by giving you this hormone right here. And the brain is like, well, I guess we don't have any eggs maturing because I'm not seeing any estrogens, so I'm going to pump more of this out. And so instead of having one egg go through the cycle, you might have 15 eggs go through the cycle, all right? So this is, we can measure your capacity to have a baby as a woman by looking at how many eggs we can put out when we fool the brain with this clomiphene. That being said, okay, so once you've established that, we can also use this as a fertility drug. And so each cycle you'll take this clomiphene for a while, and this is how you have women that have quadruplets, etc., because of multiple eggs going through the system. Awesome. Okay. Now, and up here, if you have more questions, this is a great website. It's called In Vitro. Okay. You come in right here. All right. They have kind of news and current events about fertilization in here, and you can look up all kinds of different information through here. Okay. There's also a menu that's really, really awesome. So if you have curiosity, I'm just telling you, if you get to the point, do know you can look at what you can do to get tested for fertility. How many ovaries, how many cells do you have that cycle through your ovary? That's your ovarian reserve, okay? Check your hormones, okay? Super important. We can also test males, okay? And see if you're having any issues with your sperm, the quality, the quantity, and the mobility, okay? So these are all really, really, really great resources that you can check out. Pregnancy at 1 month, okay? You can check on there. There it is. All right, so this talks about the cycling that I was talking about here, and then this comes down here and then it gives you a good description of what to expect. Okay, awesome. All right, get out of there. Boom. Okay, so we can come over here, and it talks about the whole development right there. Neither here nor there. That's you don't have to find information in there. It's there for your curiosity and for your edification. Okay. Then we come down here, let's say all the different drugs, because you're going to start conservative and it's less costly, okay? And then you get more aggressive in your approach working with your MD fertility specialist, okay? And that's when you step up to doing what's called in vitro fertilization. Okay, so this is all about the different medications. You can look at this site as well, along with the website up here about the medications you can do to improve your fertility. And down here, there are 2 amazing videos that educate you about in vitro fertilization. So what the physician will do is give you a drug so that, like clomiphene, there's another a drug that looks just like the FSH, okay, that you can inject into the patient. That way you can harvest a bunch of eggs, okay? And then in the petri dish, you expose them to sperm and you let the cells grow to a certain stage. It's called the 8-cell stage, okay? And then you take those embryos and you put them into the uterus and hope that they stick, all right? So the issue is, okay, something is keeping the egg cells from getting fertilized, so we're gonna bypass the body and we're gonna create our own little embryos. The second $1 million question is, how do we get those embryos to stick? And that's a tough one in terms of the uterus, okay? Alrighty, so last part right here, okay? There's too much folklore about, the female or maternal age underlies a lot of birth defects or developmental issues. And the reality is we get equal blame, guys. All right. The older the father or the paternal age, this is just a lot of different graphs showing paternal age down here, and there's there's 3 different graphs right here. The most important one is just the one that's going high, okay? One that's going high is showing that the older you are, the more likely you're going to have a child that has bipolar disease, substance abuse, ADHD, autism, okay? Have problems in terms of failing grades, on and on and on, all associated with the age of your sperm. Okay, guys, that's everything. Discuss your thoughts and your emotions about aging, the challenges that you have in terms of having to decide between getting yourself ahead or having children, okay? And you're educated in this, the procedures, and so I want you guys to go to town on this, all right? Very cool. All right, peace, all right? Love, and we'll see you next time.